Hello, this is presentation on radar and cancer. It was prepared at the request of the PARC organization in order to examine cancer risks associated with radar, such as the DARC system which is proposed. The presentation is based on a research I took part in. It was published in the Environmental Research. The authors of the research include outstanding experts on medicine and epidemiology. I am Michael Peleg. I am engineer working in radio communication and information theory, and occasionally for the last 15 years on radiation safety. I did the statistical analysis in this paper. The presentation includes findings on radiation and cancer from our paper. It compares radar and cellular radiation which are similar but different, and it presents the parameters which are important and should be monitored. The research was on case series of 46 cancer patients. Those were IDF soldiers ill with cancer at the end or somewhat after their military service. They served either near military radars or military communication systems, and the patient's age at diagnosis was very young, about 24 years. We analyzed two aspects. For 6 patients, we knew the number of the soldiers serving in the unit, so we could and did perform direct analysis of the cancer risks. On the group as a whole, we analyzed abnormal cancer characteristics, in particular the percentage of patients who had haemolymphatic cancers, which are lymphomas and leukemias. Such abnormal characteristics of cancers indicates that there was some carcinogen which modified the cancer characteristics, made them different from the general population, and was strong enough to be noticeable. The results on all cancer rates are on this graph. We show the number of cancer cases over the years from the beginning of the military service. There were 6 patients, and in such a group, accounting for the age of the patients, there should be less than 1 in the normal public and population. This means that the cancer risks rose about 8-fold. The group was small, so the true risk could be smaller or larger. However, we have seen and cited similar results in previous published researches. It is a characteristic of groups of young people exposed to strong radiofrequency radiation. Above the group as a whole, the percentage of haemolymphatic cancers was 41%. It was 19 patients out of the 46. The percentage in the general population in those ages is only 22%. This abnormal characteristics is consistent with previously published researches. We will show it in future slide. This research focused on haemolymphatic cancers. There are many publications on other cancer types caused by the radiofrequency radiation. Our findings are consistent with 5 previous studies. Mainly the highly abnormal and statistically significant haemolymphatic cancer percentage, which was high in all the groups, and also high cancer risk, haemolymphatic and others. It is consistent across 6 groups of patients in Poland, Belgium, and Israel. And the studies involved different exposure from different radiofrequency radiating equipment, and the cases occurred over decades. The only common factor common to all those groups was the radiofrequency radiation. it is unlikely that something else caused those cancers. The results from the 6 groups are presented on this graph. The graph presents the observed to expected ratio. In normal population, the observed and the expected number of cancer cases is the same, and this ratio should be 1. This is the red line on the graph. As we see, in all the 6 groups, the number of cancer cases and the percentage of hematolymphatic cancers exceeded very significantly this value, which means there is something common and seriously bad in those 4 groups. Our conclusion of carcinogenity is based on the IARC classification of radiofrequency radiation as possible human carcinogen on at least 6 papers which propose updating this recommendation to probable or sure carcinogen. Also, the carcinogenity was reported in many epidemiological papers and in studies on cell cultures and on possible physical mechanisms through which the non-ionizing radiation can modify cells and cause cancer. Of course, the results of our study and the similarity of it and those other 5 groups is further makes the conclusion of carcinogenity more strong. The next slide compares exposure from cellular phone and from radar. The radiation in both cases is the same radiofrequency radiation. It is non-ionizing, but there are differences. The radar exposes the human with a whole body radiation. This is in contrast to the mobile phone, which exposes only part of his head. So about 10 more many cells are exposed by the radar, and so the possibility that the radiation causes cancer should be expected to be 10 times higher. The radar must apply vastly stronger transmit power to detect targets flying tens of thousands of kilometers from it. Now the radar tries to direct its transmitted energy into some desired direction. However, there is a spillover called the side lobes. Even when the antenna is designed to radiate in certain direction, it radiates in almost all directions, and the intensity of this depends on the side lobe level of the antenna. The radar uses pulses with extremely high peak level, and this peak level can have extreme biological effects, as shown on this slide. The red line on this graph shows the transmitted power of the radar as it evolves over time. Most of the time the radar does not transmit, but it transmits huge peak power in short pulses, and the safety standards control only the average level. So they conclude that on the average the transmitted level is low and is permitted. To be sure, those pulses occur many times per second. There are 2 important parameters of human exposure. The first is the average power density. It is measured, for example, in microwatts per square centimeter. It is regulated by the so-called safety standards. Those are designed only to prevent harm by overheating, and they do not account for carcinogenity. The second important parameter is the peak power density. With given average power, the peak power in radar is expected to be about 1,000 times higher. It of course depends on the radar type. The biological effects could be stronger. There was a very good animal experiment with radar-like signals which increased cancer rates in animals about 2 or 3-fold. And most of the patients in our study were radar operators. The exposure levels of most of the cancer patients in the 6 groups I presented were exposed to levels which are somewhere between the typical citizen exposure level and between the much higher levels permitted by the so-called safety standards. Some radiation levels are presented in this table. The exposure of a typical citizens on electrommunity from the antennas of cellular base stations is about 10 or 10 microwatt per square centimeters. The peak level is about 5 times higher. The Swiss and Italian standards permit 4 to 10 microwatts, which is more or less the typical level people are exposed to now. The Israeli radiation limit is 100 microwatts, which is higher. The ICNIRP recommendation for the general public is to permit 1000 microwatts, which is much higher than the typical level. The occupational recommendation is 5000, and the ICNIRP recommendation for the maximal peak level is 5 million, and even this limit was cancelled by the ICNIRP in 2020. The last slide is my recommendation about the DARC radar. I think the radiofrequency radiation exposure from the radar should not be larger than the exposure from typical cell phone mobile antennas. This means that the average levels should be no more than 1 microwatt and the peak levels should be limited to 5 microwatt per square centimeter. And the DARC designer should control those levels starting from the analysis in the preliminary design and continuing to the operation of the radar. Those levels should be always fully accessible to the public. There are means to reduce exposure. Those are sighting the radar far from human beings, shielding by topography, for example hills between the radars and between the exposed village. The design of the radar could include very low side lobe level and some attempt to reduce the peak level by new waveform design. Thank you, and I wish you success with dealing with this difficult issue.